Founded in 2019 under the name Prometheus Space Industries, the company that would become Latitude has undergone significant evolution in its identity and objectives. The company changed its name to Venture Orbital Systems before finally settling on the name Latitude to better reflect its expanding scope and strategic direction. Originally, the company's focus was narrowly set on providing launch services for CubeSats. However, with the market's shift towards large, low Earth orbit mega constellations, Latitude recognized the need for a more robust and powerful launch vehicle. This realization led to a strategic pivot, venture into space mobility and broader space technology applications. Latitude's approach to rocket development mirrors that of industry leaders like SpaceX, employing an iterative design process to build a reliable launch vehicle. This method allows for continuous improvement and adaptation to new technological and market demands. With ambitions set for 2025, Latitude is gearing up to place small satellites into orbit. By 2028, their launcher is expected to handle payloads of up to 200 kilos into low Earth orbit, signaling a significant increase in capacity. The company has secured over $55 million in funding, a critical resource for scaling operations to meet the 2025 launch target of their first orbital vehicle. This financial backing underscores investor confidence in Latitude's vision and execution strategy. Latitude boasts over 100 employees and is on a trajectory of continued growth, both in workforce and technological advancement, aiming to carve out a significant niche in the competitive space launch sector. Let's look at the technology Latitude is using to create its orbital launch vehicle. The Navier engine. Let's first look at the engine that powers the launcher. The first version of the Navier engine was developed in under 2 years, with initial firings conducted in the last quarter of 2022. The second version of the Navier engine is expected to have double the thrust of its predecessor. This will directly translate into a substantial boost in payload to low Earth orbit. This improvement is crucial for meeting the growing demands of the small satellite launch market. Recognizing the strategic importance of this engine, the French government, through its space agency, provides funding to Latitude in 2020. This support underscores the importance of commercial space startups to France and to Europe more widely. A notable aspect of the Navier engine's design is its construction using 3D printing technology, a trend increasingly adopted by space startups for its efficiency and cost-effectiveness in manufacturing. With development on track, the Navier engine is set to power Latitude's first orbital launch, aligning with their ambitious timeline for 2025. This engine's evolution is a step towards enhancing France's presence in the global space launch market. The Zephyr vehicle. Zephyr is designed as a 2-stage rocket, initially capable of placing up to 100 kilos into low Earth orbit, with plans for an upgraded version by 2028 that could double this payload capacity to 200 kilos. Stage 1 consists of 7 Navier sea-level engines, and Stage 2 has 1 Navier vacuum-optimized engine. The dimensions of the vehicle are length of 19 meters and a diameter of 1.5 meters. Latitude's launch facilities at Saxford in Scotland and Kourou in French Guiana means Latitude can offer a wide range of orbital destinations. Located at a high inclination, Latitude can efficiently access sun-synchronous orbits, which are ideal for Earth observation satellites due to their consistent lighting conditions over time. On the other hand, the equatorial position of Kourou provides a big advantage for launches requiring high energy, such as those destined for geosynchronous orbits, which are crucial for communication satellites. The proximity to the equator also boosts missions aimed at deep space or planetary exploration, where the Earth's rotational speed adds a natural boost to the rocket's velocity, reducing the fuel needed for escape velocity. Together, these launch sites empower Latitude to cater to a wide array of mission profiles, from routine satellite deployments to ambitious interplanetary missions, showcasing their capability to serve both commercial and scientific space satellites comprehensively. Let's briefly go over some of the milestones for Latitude so far. They had a successful ignition of Latitude's mini rocket in Scotland. Latitude continues to develop its micro-launcher with a successful ignition of the Navier engine in Saxford, Scotland. The successful ignition of the engine confirms that it has good mechanical and thermal resistance. or to put it more plainly, it did not explode when started. The Navia was fired at 6% of its maximum performance. A second campaign will be carried out later with more sensors added to the engine, and the engine will be pushed to its limits. Mid-2024, test facilities built in Vatry, France. This location offers the perfect blend of accessibility and isolation necessary for rocket engine testing. Spanning over 3 hectares, the facility is one of only 2 in France dedicated to testing liquid propulsion engines, playing a pivotal role in the development of Latitude's rocket engines, especially for their Naviair project, which focuses on 3D printed engines. As of mid-2024, Latitude has been actively improving this facility, focusing on creating a custom-designed test bench for their engines. This setup includes structures to support the engine and manage fluid lines, as well as systems for conducting hot-fire tests, aimed for their first significant test in the near future. The significance of this facility goes beyond testing though. It helps advance space technology within France, fostering innovation and creating employment opportunities. Upcoming events. Let's examine some of the outstanding tasks for Latitude before it can launch its first vehicle into orbit. Latitude plans to conduct their first hot-fire tests at their new facilities in Vatry, France, expected sometime in late 2024. Simultaneously, they are preparing the launch site at Saxford, Scotland. This involves not only building the launch pad, but also setting up and testing all the necessary ground support equipment, including fuel storage and delivery systems, to ensure readiness for an orbital launch. In light of recent space industry accidents, such as the ABL pad fire in Alaska, and the incident involving Rocket Factory Augsburg at Saxford, Latitude needs to be particularly focused on bolstering fire safety systems and refining risk management strategies. The first launch of their rocket, Zephyr, is scheduled for 2025. So far, Latitude's engine development and hot-fire testing campaign are proceeding according to schedule. We wish Latitude the best of luck and are eagerly anticipating their inaugural launch from Saxford, Scotland. We'll keep you up to date on their progress. Okay, that's it for this week. Be sure to subscribe to get the latest news on commercial space startups around the globe. From rocket launchers to space stations, orbital tugs, lunar landers and more. If it's a commercial space startup, we cover it. See you soon.